few of the elements of the blockchain, and then we have seen what are the different elements are there, what are the structure of the block in blockchain, and what is the structure of the block in Bitcoin, and what are the transaction field, what are the header fields that we have seen. And then we have seen that the blockchain or the Bitcoin, the application of your blockchain, they are the distributed systems. That means they all comes on a common consensus, so that every node in that network can participate actively, and there is no centralized node who can control the entire block itself. So today we'll try to discuss some of the consensus in the blockchain and what are the different consensus are there, and we are going to talk the technology part of your consensus in permissionless consensus. We are not, but we will try to discuss the permission consensus, but we are not going to do any trading for that. Okay, only the technology part we will discuss. So in this, we'll see what is the consensus in our blockchain or Bitcoin. So in this, if you see that the consensus is a process of an agreement between the distributing or the distrusting nodes in the distributed network on a final state of your data. So in order to achieve the consensus, different algorithms can be used, but it is easy to reach an agreement between two nodes. For example, in the client server system, we have only one client, and there will be one server. Suppose in client server system, the agreement will be between your client and your server itself. So, but when the multiple nodes are participating in a distributed system, as we said, your blockchain technology or Bitcoin technology or the distributed system, so they can participate in the network at any time, they can leave the network at any time, and there is no centralized control over. So when multiple nodes are participating in that, then how the consensus is that can be agreed among the users is the important task in this, or important the part to discuss in this distributed blockchain system. So when multiple nodes are participating, then they need to agree on a single value. So it becomes very difficult to achieve the consensus in this case. So this concept of achieving the consensus between the multiple nodes in a distributed consensus as accepting of achieving the consensus between multiple nodes, we call this as your distributed consensus. So what are the different consensus mechanisms are used in the distributed consensus to make that happens possible in the Bitcoin or the distributed blockchain system. So this consensus mechanism is step-by-step that are taken by all or most nodes in order to agree on a proposed state or the value of your network. So these consensus, there are some various requirements which can be met in order to provide the desired result in the consensus algorithms, maybe in Paxos, maybe in the Rafter consensus algorithms. So for more than 3 decades, this concept has been reached by computer scientists in the industry and the academia. So consensus mechanisms have recently come into the limelight and gained much popularity with the advent of your Bitcoin, which is the application of your blockchain system. So there are various requirements which must be met in order to provide the these desired results in this distributed consensus mechanism. So few of them, we can see this. The following are few requirements to achieve the desired results in this consensus algorithm in the distributed network. One is your agreement. As said, all the honest nodes that decide on the same value is the first part. That is the first requirement for this consensus mechanism. Second is the termination. Means all honest nodes, here we are using the terminology honest, so we are trying to ignore the malicious nodes or Byzantine nodes. So all honest nodes terminate execution of this consensus process and eventually reach a decision is another requirement. And third is the validity. So the value agreed upon by all honest nodes must be the same as the initial value proposed by at least one honest node in the network. Next one is the fault tolerant is another requirement for any consensus mechanism. It may be your distributed or it may be your what you call public consensus or private consensus or tokenized consensus. We'll talk about them. So the fault tolerant is another requirement for this consensus mechanism, that the consensus algorithm should be able to run in the presence of faulty or malicious nodes, or we also call this as your Byzantine nodes who try to disturb the entire network. And for the most requirement part is the integrity part. So this integrity is the basic requirement and very important part which plays a major role in this consensus mechanism, where by node make the decision more than once. So the nodes make decision only once in a single consensus cycle or in the single agreement part. So what are the different types of your consensus mechanisms are there? Means there are many consensus mechanisms are there, or there are but some common types of your mechanisms we can summarize based on these requirements. As you can see, one in the network you may find some malicious nodes and you may find the all honest nodes. So in one we can say that the types of consensus mechanism is categorized as your Byzantine fault tolerance based. Another one is your ledger based consensus mechanisms. So in Byzantine fault tolerance mechanism, with no computing intensive operations such as the partial hash inversion. So this method, the Byzantine fault tolerance based consensus mechanism method, that relies on simple scheme of your nodes that are publishing single messages only. So eventually when a certain number of messages are received, then an agreement is reached. So it is very common, the important part to solve this fault tolerance based Byzantine. As said, so by the operations such as your partial hash inversion. So in this case, what happens? Every node that are publishing the signed messages. So once a limited number of messages are received upon having the same agreement, in Bitcoin we have seen that the validity will be checked for some 6 nodes for the transaction confirmation. Another type of your consensus mechanism is your ledger based consensus mechanism. In this ledger based mechanism that requires nodes to compete for the ledger election lottery, and the node that wins it that process a final value of that ledger. So means what? In this, many practical implementations that have been proposed, such as the Paxos mechanism or your the rafter mechanisms to implement these consensus. One is the Paxos, another one is the raft mechanisms to develop these consensus algorithms. So the famous protocol which was introduced by the Leslie Lamport, uh, we can simply write as your Lamport, which we have done the digital signature process also in 1989, I think, around. So in Paxos, the nodes are assigned the various roles, such as the Paxos may be the proposer, or Paxos may be the acceptor, or Paxos may be the simply learner from this proposer and the acceptor. So the nodes are the processes are named the replicas, which we discussed in the previous class. That every new block that must be up to date, and every node in the network should have one copy of that. We call it as your replicas, and every node are named as your consensus. That the replicas or consensus is achieved in the presence of your faulty nodes. There may be malicious nodes will be present in the distributed network by the agreement among the majority of nodes that will give you the byzanter fault tolerance based one. But another alternative in this Paxos, but another alternative to this Paxos is the Paxos consensus mechanism is your the raft mechanism. So in this raft mechanism, which works by assigning any number of three different states which are given to a either they can be the follower or candidates or your leader to the node. So the leader to the node. So these three different roles assigned in rafter, whereas in Paxos they may be the proposer, they may be the what you call the acceptor, or they may be the learner. The same way in rafter, the names are changed whether they are follower or candidate or the leader to the node of that. So a leader in this case, in the raft algorithm, is selected after a candidate node receives enough votes, and all changes now have to go through the leader. So who commits the proposed changes once replications on the majority of follower node is completed in this process of your consensus mechanism. So the more detailed about the theory of consensus mechanisms from the distributed system point of view, that is beyond the scope of the our topic at this moment, but we will discuss these Paxos in details in the coming lectures. How these algorithms are works together. So then, the type of blockchain consensus, we'll discuss these in briefly, and then we'll in upcoming lecture series we go and talk more about discuss more about the technical details of each of these blockchain consensus. The first blockchain consensus, we can say this as your simply the public blockchain, or what you call the the public ledger or distributed blockchain, that we can name this as the different. And another one is private blockchains, and you will have the semi-private blockchain consensus. You will have the tokenized blockchain consensus. So that is based on the way the blockchain that evolved over the last few years. It can be divided as your public blockchain consensus technology, or private blockchain consensus technology, or your semi-private blockchain consensus technology, and various one. So what is this public blockchain consensus technology means? As the name suggests, that the blockchain are open to the public, and anyone can participate as a node, as we discussed in distributed systems, in the decision making process. So the users may or may not be rewarded for their participation in this public blockchain consensus. So these ledgers are not owned by anyone and are publicly open for anyone to participate in this public blockchain. So all users of the permissionless ledger maintains because as we said that no one or the anyone and the anyone can prepare the ledger, and that is open to every other one. So we call this public blockchain consensus as your permissionless less blockchain consensus or permissionless model, we can say that. So there is no need to take permission from anyone. So this permissionless ledgers maintain a copy of the ledger on their local nodes and use a distributed consensus mechanism. Maybe it may be your Paxos or it may be your RAFTA mechanism in order to reach a decision about the eventual state of the ledger. So these blockchains are also known as your permissionless ledgers or permissionless model, we can say that. And another type of your blockchain is your private blockchain, as we say. The name itself says that private blockchains, as the name implies, are private and are open only to a consortium or group of individuals or the organizations that has decided to share the ledger among themselves itself, but it is not available to any other users. So suppose if there are few organizations, like we call the organization 1, the organization 2, and any organization 3, only they can share the ledger which is prepared either by organization 1 or organization 2 or organization 3. But these are not available if any other organizations are there which are out of this particular network. These ledgers are not available to them. So we call that the private blockchains. So this is basically used for the doing payment transactions from one organization to another organization in limited way. Not in public, means it is not a public trade market type. Third one is your semi-private blockchains. So here part of the blockchain is private and part of it is public. So we called it as your semi-private blockchain consensus. So the private part is controlled by a group of individuals, whereas the public part is open for the participants by anyone in the network. And another type of your the distributed blockchain, we call that side chains. So in this side chain, it is more precisely known as the pegged side chains. So that is a concept whereby your coins can be moved from one blockchain to another and move back. So as we said, if we have blockchain 1 and blockchain suppose 2, and in that blockchain whatever the blocks are created like B1, B2, B3, B4, as it moves creating the blocks. So the coins can move from one block to your another block chain. This chain, the coins can move from here to the new blockchain, and any updated coins are there from that, it will come back to the what you call the previous block, that we call the side chains. Okay. That means any updated block is there in this. Suppose block 5 is there, if it is created, that block file can be appended in this one. So the coins can move from one blockchain to the another, the blockchain one. So the common uses that include this creation of new alternative coins of your Bitcoin. We call that alternative cryptocurrencies. So whereby coins are burnt as a proof of the adequate stake. So there are two types of side chains. The example which provided for this burning coin is applicable to one-way piggyback of sending coins from one blockchain to your another blockchain path. So similarly, another type of the consensus for this blockchain in distributed blockchain is permissioned ledger, as we said. In permissioned ledger means the permissioned ledger is a blockchain consensus mechanism whereby the participants of the network are known and already trusted, so that we call the permissioned blockchain. Permissioned ledger is there. Only some permission is given to any one user in the network who can create the ledger itself. The ledger consists of your block header as well as your transactions. So in permissioned ledgers, they do not need to use a distributed consensus algorithm like Paxos or your Raftas. Instead, just an agreement protocol can be used to maintain a shared version of your truth about the state of your records on the blockchain. So there is also no requirement for a permissioned block of your blockchain to be private, as it can be a public chain but within the regulated access body of that particular limited or closed circle. And we use the distributed ledgers also, as the name suggests that this ledger is distributed among its participants in the distributed network and spread across the multiple sites or your organizations. So this type can either be private or public distributed ledger. So the key idea is that unlike many other blockchains, the records are stored in the contiguously instead of your sorted into some blocks, and this concept is used like the Ripper type or Ripple type. And another the distributed the consensus algorithm which is used by some shared ledgers, we say. So in this shared ledger, as the name implies that the generic term that is used to describe any application or database that is shared by the public or consortium is another type of your blockchain consensus. Another one is fully private and the proprietary blockchains. So in fully private and the proprietary blockchain consensus, it is perhaps have no mainstream application, as they deviate from the core idea of your decentralization in the blockchain technology. But nonetheless, in a specific private settings within a organization, there might be a need to share data and provide some level of guarantees of the authenticity of the data. So these blockchain consensus could be useful in some scenario like that, in a limited range of users. They comes together and form the blockchain. And with that, some consensus known as your tokenized blockchains. So these blockchain consensus are standard blockchains that generate the cryptocurrency as a result of your consensus process via either mining or via the initial distribution. So that is tokenized blockchain. Those who are having the token, they can participate to agree with the consensus. And another one is your tokenless blockchains, like your public and private type, tokenized blockchain consensus, and your tokenless blockchain consensus will also be there. In this word, these are probably not really blockchain because they lack the basic unit of your transfer of value, but are still valuable in situations where there is no need to transfer value between nodes and only sharing some data among the various already trusted parties inside the network. So these are some types of your the blockchain consensus, but we are going to mainly focus on the public blockchain consensus and some of the private blockchain consensus to talk. But in generally, they are categorized into different types of your blockchain consensus mechanism. So we'll see one is, as we said, the public network or the permissionless model of your the permissionless model consensus, that is also known as your public blockchain consensus. So what is happening in that? This permissionless model is the open network. Open network means any user can join in the network at any time. Any user can leave the network at any time. So it is a ad hoc network. We can say that there is no the permanent topology. The topology of your network always change. Topology means at a instant of for an instant of time, some in that network maybe 5 users are there. As time goes on, the number of users may either increase in the network or maybe decrease in the network. So as the name itself says that permissionless, that means anyone can join the network and start doing the transactions, initiate the transactions in that network. They don't need permission from any existing users. So participants are free to leave the network and can join the network. This is the basic property of your permissionless model or in the public blockchain model. So as we discussed in the Bitcoin, they can join, and when they are joining, what is the first steps that they need to take? When they join, they give their identity to the some of the existing nodes. Upon verifying that identity by existing nodes, in terms of, because the new node is sending a request for the list of addresses in the network. So then the list of addresses which is requested by any existing nodes, they can simply transfer the list of addresses in the network to the new node. Then new node use those list of addresses to broadcast the new transaction of your new node, and those transactions will be updated by the miners in the network when they are trying to generate the new block for transactions. But they, any new node that not taking any permission from any of the existing nodes. So the assumption in this permissionless model is, it is assume the users assume that more than 50% of the participants, they are honest in this permissionless model, so that they can provide the updated block or updated replicas. So it is happening how a society cannot run if the majority of its participants are dishonest. At least 50% of participants are honest, then only possible to run. So in the same concept, which is used in blockchain or in Bitcoin technology, that at least 50% of the participants should be honest. They can provide the updated replica or updated copy of your block to the newly joining users. So the example for this, the permissionless model is, one is your Bitcoin, another one is the Ethereum, which we will discuss about the installation of your Ethereum and creating a Bitcoin network, distributed network by using this Ethereum on a virtual machine. That very soon, after your exams, we are going to talk more about this Ethereum, how to install it and create the network on your own as your assignment 2, lab assignment 2. So these are the basic the examples of your permissionless model. So any user can be the active participant in this permissionless model. So we'll try to make this assignment as the individual assignment, but whoever created the Ethereum network, they can collaborate with any other for doing more exercise, for more understanding. For shining means as a group assignment. Submission of assignment is individually, but you can create the permissionless model in a group. Because if you create in a group, everybody having their own unique identity, everybody can try to become as a miner. They can prepare a ledger. That ledger can be distributed among the user by using. But mostly, if you are using the virtual machines, then you can create your own network on your machine by forming number of nodes, maybe 5 nodes, 6 nodes like that, to generate the hashes. Yeah. So then the consensus in the permissionless model having some challenges. As we are saying that any node can join at any time and any node can leave at any time. So what are the different challenges that these nodes can face? So the challenges, we can say that participants do not know others. In permissionless, when trying to join in the permissionless model, we don't know who others are there in that network, whether they are honest users or the dishonest users, don't know. So that is the challenging one. So that cannot use the message passing simply for any unknown users in the network. That is one challenge. Another challenge is because if any new node comes and joins, suppose we have a network, node 1, node 2, node 3, suppose node 4 are there. So they all are having some distributed consensus, and they generated some blocks, and those blocks are shared by those users. Suppose like the block 1, the same block with the node 2, same block with node 3, same block with your node 4. But if the new user coming, the N5 new user is there, so this user not known to anyone, suppose in this network, then they are unknown. So for this unknown user, how can these nodes can trust and transfer the list of addresses? List of the user addresses here. What are the list of addresses here? If N1 try to provide the reply or the response to this N5 request, list of addresses you can find in terms of reply from your N1 to N5 as who all are there here. N1 is there, N2 is there, N3 is there, and N4 is there. If this user is not known to anyone from N1 to your N4, then what is the the guarantee that this user is a trustworthy user who is going to join in the network? So for them, it can't use the message passing that this is one challenge. There should be some mechanism is there. That means N5 should prove himself that I am a honest user, so that allow me in that network. Correct. Another challenge in this permissionless model is anyone can propose a new block. Okay, so as N5 is newly joined in the network and said that, okay, I have a block I can propose, but how to trust N5? So who is going to add the next block in the mechanism, in the blockchain mechanism, is another challenge. Whether it is N5, N1, N3, or existing user or new user. Similarly, another challenging is the network is asynchronous, right? The reason is some users may have the well-configured computer or advanced computers, like their processor speed may be high, they are having more storage area, like the what you call the storage database. Some may have limited database, and some may have the processor speed may be less. So in that case, there will be always a asynchronous. So we do not have any global clock that everyone have the same processor speed to generate the block. So in Bitcoin, we have seen that Bitcoin block rate, the rate may be changed, right? So theoretically, a node may see the blocks in a different order, as a different order. If you see that in this blockchain having three blocks, B1, B2, B3, and there are three users are there, then the third one trying to get the updated copy. So in this case, the first user is giving the block 3 information, and that is received first, and then the next block is received from this user. Suppose this is your Bob and this is Alice. So then the order is different. First block 3 is received and second your block 2 is received. So a node may see these blocks in a different order and to decide, because the mining process of this Bob is higher than the mining process of your Alice, suppose. So in that, validating that is more important. So in this case, as we says that any type of the monopoly needs to be prevented in this permissionless model. So how it is, a single user or a group of users should not gain control. So we don't trust anyone in this network in permissionless. So these are few challenges in open network. So how to gain these few challenges? So if you remember when we talked about the distributed consensus which is proposed by these users, FLP, the Fischer, Lynch, and the Peterson in 1985, I think we talked about this. They proposed that in the network, it may be your synchronous network or asynchronous distributed network. That means every user in the network may have the same clock speed or clock rate for processing or mining your blocks. So in synchronous, I'm sure that I will get the message with a predefined time threshold, that in every 10 seconds or in every 10 minutes I will get the new block. That is synchronous. In asynchronous, I'm not sure that where and when the message will be arrive. That maybe in 10 minutes we may receive the new block, or in 10 seconds we may receive the new block. So there is a asynchronous in that case. So there, what is important in that distributed network, that initially, suppose node 1, node 2, node 3, these three nodes are there in the network, in the distributed network. So they agreed upon a particular agreement, the distributed consensus agreement, like assume that Paxos. In Paxos, they agrees that in every 10 seconds, the new block will be generated and will be distributed among or flooded among all these users. Okay, but after some times, the node 1 thinks that become the Byzant node, thinks that why should I waste my power consumption, why should I waste my processor energy and the storage, then this node may become the Byzantine node, malicious node, and start that I'm nowhere going to participate in the network. So when this node becomes inactive, then these links which is established between N1 to N3 and N1 to N4 become your link failure. Correct? Because actively participating as the wantedly inactive from the network. So that gives the failure in the network, that the crash fault. So a node stops responding for the request of other nodes in the network. So then how to overcome from that problem? This FLP impossibilities also address that the link fault or the network fault, that is due to a link fail to deliver the message inside the network. One is user can act that why should I participate actively. Second, there is a possibility of network failure. And third, the third user actually not a legitimate user, but node can start behaving like a malicious node. So these are the link failure, another impossibilities which is addressed by these users. And another one is they addressed in this case is the impossibility theorem. So consensus is not possible in a perfect asynchronous network even with a single crash failure. Single crash failure. That means if a node is connected to multiple nodes, suppose node 1 or node 2 or node 3 or node 4, and this is a node 5 node, and if this node becomes the faulty node, then this faulty node says that I'm no more participating into the network, I don't want to waste my energy. Then what happens? All these nodes become isolated, right? N1, N3, your N2 and N4 become isolated because of that. So that gives, this is impossibility theorem in this. So cannot ensure safety and liveness simultaneously. So we discussed this safety and liveliness. So in the distributed consensus which is proposed as the Nakamoto, Satoshi, in the first paper of your Bitcoin which was dropped in the network, they named as your Nakamoto, the consensus, they requires the proof that whatever the blocks are there, they must be accurate and having the final value, and define the term as there must be a safety and liveliness dilemma must be there. So to prove this or to have this safety and liveliness, this Nakamoto consensus algorithm is having proof of work. So in proof of work, every participant who is actively participating in the network, they must generate a hash value. So we have seen this proof of work in the previous case. So that hash value should be, or we call that target hash, which is used as a header field of your new block, must be greater than the previous hashes. So then it gives the liveliness. So in liveliness means it is important than your safety first. So what is liveliness is saying? The output will be produced within a finite amount of time. It must produce, suppose in if the agreement is suppose in 10 seconds, then the output will be produced by any of the miner that should be within the finite amount of time, this 10 seconds of time. So that eventually the terminates if any blocks comes after the 10 seconds. So the immediate focus is on the liveliness with a minimum safety. So what safety is saying? It having the correct process will yield the correct output. So what is that correct process? We call the difficulty. Difficulty means doing the mining process. So this the minimum safety that guarantees, and full safety will ensure the eventual in this case. So in that case, if any node behaves maliciously, that can be identified, and simply their digital certificate should be revoked from the network. So that those faulty nodes can be removed from the network. That is another challenging process. We don't go in detail about that one, but if anyone wants to do research in such site that how to identify a malicious node in the network, that is another based on calculating the trust values of those nodes in the network is a different process. So on that particular topic, I have done some research and published for calculating based on your threshold cryptography to compute the trust behavior value of any node in the ad hoc network. So because all these distributed networks are the blockchain networks are the ad hoc networks, anyone can join and anyone can go, but how to believe that? So based on by sending some dummy packets through those nodes and check whether those nodes are forwarding those packets to the neighbors or not. So based on that, the trust values will be calculated, and based on the trust value, whether they are going to be included in the network or not, that can be another different topic of that. Yeah.
Is that a possible? How do we pick for our final paper? How to find malicious nodes?
Yeah, that's possible. Okay. So that's the reason. Means how to find a malicious node is one, and how to what you call the terminate that malicious node from the network. The process of that finding and termination.
Okay.
So revocation is important to make your network secure. Yeah.
Okay.
So that is also related to our blockchain only.
Okay. Thank you.
Yeah. So next comes to this breaking this safety versus this liveliness dilemma. As we said, safety liveliness means it must have the accurate or the output must be the accurate and in a finite amount of time. Whereas safety is the correct process will be yield to correct output. So the breaking this dilemma between this your safety versus your liveliness, if you see here, we have considered block 1, block 2, block 3, right? In our previous slides, consider block 1, or block 2, and your block 3, suppose. So there are 3 users in the network. Sorry, there are n number of users in the network. But out of n number of users, there will be 3 users, they want to act as a miners. Means they want to generate a blocks. Or we call the difficulty acting. Or we call simply as your miners. So what is the job of these miners? Whenever the new transactions are there with any existing user or the new users, like your transaction 1, 2, 3, transaction 11, 13, 45. So any transaction blocks are there. Suppose block 1, your block 2, or your block 3. In this case, if you observe that these transactions are unconfirmed transactions. They are simply generated by the participants in the network, but they are unconfirmed. Someone should be confirm these transactions in the network, either from miner 1, miner 2, or miner 3. Then only those transactions will be added to your block. So in this case, all the transactions are done by the individual users in the network and broadcasted in the network. So these transactions are received by your miners, miner 1, miner 2, miner 3. Initially, these miners don't have any transactions. Upon these transactions are broadcasted in the network, the miner 1 received one transaction 16. Miner 3 is also received the same transaction 16 when this transaction 16 is broadcasted in the network. So here you can see there are 3 miners are there in the network, but miner 1 and miner 3 received, whereas miner 2 is not received in this. At this case, can we say that this network is a synchronous network or the asynchronous network? It is asynchronous. Some nodes received and some nodes not received. So then in the next time duration, another transaction done by another user in the network, that is transaction 17. So transaction 17 is also received by miner 1, miner 2, miner 3. So all the newly generated transactions are placed in their transaction ledger. Okay. So after the next time duration, at time t1, only miner 1 and miner 2 receive transaction. At time 2, miner 1, 2 and 3, miner 1 and miner 3 receive transaction. At time 2, minor 1, minor 2, minor 3 receive transaction. Okay. Similarly, at time 3, all minor 2 received and minor 3 is received transaction. So in this asynchronous network, if you see at time durations are at different time intervals, different transactions are received by different miners in this case. So at the next time, by in that fashion, in that the way, all the miners they try to receive the transactions at time intervals 1, 2, 3 like that, T1, T2, T3, and so on. It's supposed to end transaction. So after these transactions, after this transaction time intervals, when the time is given to achieve the safety and liveliness, in the liveliness, what is there? Within a finite time period, the collected transaction should be broadcasted, right? So now these are the transactions which are received by miner 1, 2, 3. They try to broadcast this. So to do that, what is the first process? We said the safety. Safety one means the next block should be correct. It should follow the correct practice to collect all the transactions timely and assemble them to generate a new block of your transaction. So the transactions are verified by every user in the network. Once it is verified, then the block contains the correct hash and nonce, and that will be broadcasted. This is safety scenario. Okay. Comes to the next one. This can be ensured. Which one? This safety one can be ensured. The block mined by the miner is verified by all the users. Correct. So the next one is safety 2, that all the miners should agree on a single block, either the block of your miner 1 or block of your miner 2 or block of your miner 3. They should be agree on a single block, all these miners. Okay, so the next block of the blockchain should be selected anonymously. So in this case, the miner do not know each other, because they started collecting the transactions and trying to build, but they don't know each other. In this case, who is miner 2, who is miner 3, not known to your miner 1. Similarly, your miner 2 not known to your miner 1 and miner 3. So how can they agree on the same block then? So to agree on the same block, what they need to do, to agree on the same block, because your miner 1 is having 16, 17, 31, 87, 49, 37, and here is having different transactions, so if you see, some transactions are common in every miner's block, some transactions are uncommon. Then how to agree? Yes.
What if the block with the most common transactions and the least uncommon transactions?
Yeah. So before that, one step is every miners, they need to broadcast their collected transaction block. Yep. So these collected transaction blocks received by other miners also. Then other miners compare the newly received transaction block with their mining block. If any new transactions are there, or transactions mismatching, those mismatched transactions can be accommodated in their own block. Right? So once they accommodate in their own block means, suppose for example, miner 1, if you take, miner 1 is having 16, 17. When miner 1 receives the block of your miner 2, then miner 1 is having 16, miner 2 is having 17, so miner 1 is having 17, miner 2 is having 22, but miner 1 is not having 22, so miner must update it that transaction 23 should be in his block of transaction. The same kind of the miner 2, when miner 2 receives the block, initial block, not this updated one, miner 2 is not having miner 2 is not having 16, so miner 2 has to update the transaction 16, which is there available with the miner 1 but not available with your miner 2. So this can be happen by exchanging them. So the new blocks will be generated. So here the competition starts. Who will fastly add all the transactions in one block and try to publish that, or broadcast that transaction block among all the network. So every other node in the network who gets the updated block will become the winner of that mining reward. Yes, please.
I'm assuming that transactions are sort of only added into blocks if they have the proper timestamp that it where transaction 17 it would have a later timestamp than transaction 16. So miner 2 says, "Oh, I missed the first one. That should go here."
Yeah, they can do that.
Okay.
They can do that because at this point they're trying to collect the transactions, but not yet confirmed.
Okay.
Not yet confirmed means after verification confirmed, right? Your point is correct for verification.
Okay.
Once
Right.
verification
We're not
done,
confirming right now. We're
yeah,
just saying, "Hey, do I have all of the things that everyone's got?"
correct.
Yes.
Yeah.
Okay.
So now they are ready to publish. If miner 1 is supposed faster, miner 1 can publish the same transaction set among other nodes.
Okay. So one of these transactions might be fraudulent, but the miners don't care because the later step of verification
Yes.
is going to catch it.
Yeah.
Okay.
Yeah.
Thank you.
Yeah. So then this will be, all these miners should agree on a single block. How they are agreeing? They are agreeing any missing transaction by your miner 1, agreeing with the new transaction which is received from miner 2, similarly from miner 3. Similarly, the same kind of operation done by miner 2 and miner 3. Then the next block of chain should be selected anonymously. And after that, what happens? Here they compromise and they accommodate because they accommodated here, right?
Yep.
And then they try to become the liveliness. Liveliness become the timely. It must compute and give. So if the time is given that within 10 seconds only every user in the network expecting the new updated block. So in new updated block, add a block as long as it is correct that contains the valid transaction from the unconfirmed transactions list and move further. And after that, what happens? They will, 2 or more different miners may add 2 or more different blocks. So after that, that will resolve this later that which block is having more transactions, which covers all other user transactions, all other miners transaction. That will become the winners. So in this case, if you see the transactions, after adding all the transactions, what are the new transactions from this user? 16, 17, 31, 87 is there for. From this user, 17, 22, 87, 37 is there. From this user, these transactions are there. They are broadcasted now. So no fixed ordering of your transactions. So no fixed number of transactions per block is there. So there should be a limit on this block size. So because at what time it should be complete means if any miner collects suppose 5 transactions, maximum block size is suppose 5 transactions, assuming that. So after collecting all 5 transactions, they can broadcast. So in that, what are the new transactions are generated? That will be verified. That the generation, the proof that is nuns, that is based on at what time they are generated, the older one or the newer one. So generation complex will come or verify that is that who is what is the none of these, the generation complexity, and after that the acceptance that one of the miner will be able to generate the proof who is having the more updated transactions and will become the winner. So in this case, when we are talking about the safety and liveliness, safety, every miner is doing the safety. Safety in the sense, correct mining process. They are collecting the newly updated transactions and assembling in the block. So that is correct process, mining process. But liveliness means within a limited time who is publishing it. Right? So after this, some the at some nuns by your mining tree that will having the more updated transactions compared to others will become, and this block will be verified by every user in the network. How they are going to verify? The verification done by digital signature. And once that block is verified, that new block will be added to the previous blockchain. So how it will be added? The new block is added, and that new blockchain will be broadcasted among the nodes in the network, so that this new copy will become the replica, updated copy, and that copy will be locally stored by every node in the network. So that is by following the peer-to-peer gossip protocol. We call the in networks we say that flooding protocol. Okay. So this is, for this point we call this is the concept of the Bitcoin application, which is named as your Nakamoto consensus of your proof of work. Proof of work. So with this, I would like to stop this session. In the next session, we'll try to discuss about remove the transaction from the unconfirmed list that we will discuss in the next class. So I hope